So we have geometric proofs, and geometric proofs deal with numbers as measures. So geometric proofs use properties of numbers, right? The algebraic properties that we went over earlier. And so here are some of the algebraic properties, right? We have a reflexive, symmetric, transitive, but of course all of them are used in geometric proofs, right? We have addition, subtraction, multiplication, all of these properties here. Why? Because these properties here, these algebraic properties, deal with numbers, right? Here A is equal to a number and B is equal to a number. And over here, right, when we're talking about geometric proofs, we're dealing with numbers as measures, right? For example, here we have, let's take this symmetric. We're saying if the measure of line segment AB is equal to the measure of line segment CD, right? Because we don't have the line above AB and CD, this is the measure of AB, this is the measure of CD. These two expressions are numbers, right? This is like the number 10 is equal to the number 10, which is why we're able to use algebraic properties like the symmetric property, transitive property, and reflexive property. Same thing here with angles, right? When we're dealing with that little m, we're not talking about the angle in the picture. We're talking about the number of degrees in angle 1, right? The measure of angle 1. The number of degrees in angle 1 is a number. It's a number. So we're able to use our algebraic properties and say if measure of angle 1 is equal to measure of angle 2, then measure of angle 2 is equal to measure of angle 1. This is symmetric property. Right? Okay. So anyhow, let's go ahead and try this first example. It's given measure of angle 1 is equal to the measure of angle 2, and measure of angle 2 is equal to the measure of angle 3, right? We want to prove that the measure of angle 1 is equal to measure of angle 3. And so we have our statements here, right? You could see here that measure of angle 1 is equal to measure of angle 2. That is a given. So I'm going to go ahead and write given. And then we have measure of angle 2 is equal to measure of angle 3. That's statement 2. We're also going to write given. Usually we write them on the same statement, but let's go ahead and look at number 3. Measure of angle 1 is equal to measure of angle 3. Well, what's the reason why we're able to say that measure of angle 1 is equal to measure of angle 3? Well, it's not reflexive, symmetric, right? If 1 is equal to 2, oh, I'm sorry, it's not symmetric, transitive, right? If 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3, right? If 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3, right? That's transitive. So I'm going to go ahead and put here trans prop. And so that's that. Very short proof. And then we have these exercises up here where we're going to state the algebraic property that justifies each statement, right? So we're here, we say if measure of angle 1 is equal to measure of angle 2, then measure of angle 2 is equal to measure of angle 1. What are we doing here? We're taking the equation and we're flipping it, right? Taking an equation and we're flipping it. What lets us do that? Well, some of you might be like, that's reflexive property. But remember, reflexive is same number is equal to the same number. And that's not what's happening here, right? We're saying measure of angle 1 is equal to measure of angle 2. These are two separate expressions. And so what lets us do that? It is symmetric, right? Where we're able to take an equation and flip it around. So that's going to be symmetric. Number 2, if measure of angle 1 is equal to 90 and measure of angle 2 is equal to measure of angle 1, then measure of angle 2 is equal to 90. And let's see. Well, we could say substitution, or we could say transitive as well, right? I would say substitution because we're taking measure of angle 1 and we're substituting with what it's equal to, 90. Right? So we get measure of angle 2 is equal to 90. But it's also transitive because we have, this is equal to that, and then 2 is equal to measure of angle 1. Then that means 2 is equal to what measure 1 is equal to. It's equal to 90, right? So I'm going to go ahead and put trans. And transitive property is also kind of very closely related to substitution property. So I'm just going to leave transitive property as our reason. So we're here and we're saying if, and remember, this is not saying line segment. This is saying the measure of the line segment AB, right? The length of it, the number of how many units long it is. So if the measure of AB is equal to RS, and the measure of RS is equal to the measure of WY, then AB is equal to WY. Well, this is clearly transitive, right? We have 1 is equal to 2, and 2 is equal to 3, then 1 is equal to 3. So again, I'm going to put transitive prop. And then here, what are we doing? We're taking AB is equal to CD, and we're multiplying both sides of the equation by 1/2. So I'm going to put here multiplication property. And then for 5, we have M1 plus M2 is equal to 110, and M2 is equal to M3. Then M1 plus M3 is equal to 110, right? What are we doing here? We're taking what M2 is equal to, namely M3, and we're substituting M3 in the place of M2 in another equation, right? So this here is substitution. So let's do subprop. And then 6 is RS is equal to RS. We have same expression is equal to same expression, and that is our reflexive property. And then for 7, we have AB is equal to RS and TU is equal to WY. Then AB plus TU is equal to RS plus WY. Well, this is kind of a little bit confusing because they took 2 steps and yeah, they took 2 steps here. What did they do? They took AB is equal to RS and they first started by adding TU to both sides. So we get AB plus TU is equal to RS plus TU, right? Addition property. And then they took this TU here and they replaced it with what TU is equal to, right? So we replaced TU with WY to get to this expression here. All right, so anyways, this one, the reason would be addition property. And then this one would be substitution property. All right, so for number 8, if M1 is equal to M2 and M2 is equal to M3, then M1 is equal to M3. This is also clearly transitive property, right? So I'm going to go ahead and put transprop. So, yeah, that's our exercises, and I'm going to end the video here.